The morning of November 3rd, 1944, outside the Belgian town of Aachen, Private First Class James Jimmy Kowalski crouched behind a half-built sandbag wall, watching Sergeant Tom Henderson stack bags in what everyone else called the stupidest way possible. 3 feet of empty air separated Henderson's outer wall from the main defensive position. 3 feet of nothing but wind and wishful thinking. "Sarge, you're wasting time," called out Corporal Davis from the standard position 20 yards south. "Stack 'em tight like the manual says. We're gonna get shelled to hell, and you're building a damn patio." Henderson didn't look up. His hands moved with practiced precision, tamping down each bag, checking the overlap, measuring the gap with his eyes. "You build yours your way, Davis. I'll build mine my way." If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Jimmy Kowalski had been in Henderson's squad since Normandy. He'd seen the sergeant do strange things before, always checking German positions with field glasses when everyone else just ducked, always studying enemy shell craters like they were textbooks, always asking questions that made the other NCOs roll their eyes. But this double wall business seemed crazy even by Henderson's standards. The German 88mm gun, universally known and feared simply as the 88, had earned a reputation as the most versatile and deadly artillery piece of the war. Originally designed as an anti-aircraft weapon, the 88's high muzzle velocity and flat trajectory made it devastatingly effective against both tanks and field fortifications. When an 88 shell hit a standard sandbag position, the results were predictable. The bag wall would absorb some of the blast, but the shrapnel and concussive force would tear through defenders with brutal efficiency. Standard defensive doctrine in 1944 called for sandbag walls at least 4 bags thick, approximately 3 feet of densely packed sand that could stop small arms fire and reduce casualties from indirect artillery. The U.S. Army Field Manual FM 5-15 specified exact procedures. Bags filled 2/3 full, overlapped like bricks, built up to chest height for firing positions. These weren't suggestions. They were the distilled wisdom of military engineers going back to the First World War. Tom Henderson had read that manual. He'd also read German ones, captured during the push through France. And he'd spent long evenings in foxholes doing something most soldiers didn't. He'd studied what happened when shells actually hit things. The concept had come to him after the Battle for Saint-Lô in July. He'd been checking casualties in a bombed-out farmhouse when he noticed something odd. A German shell had struck the outer stone wall, blown it apart, but the people sheltering behind an inner wall, separated by about 3 feet of empty barn space, had survived with only minor wounds. The outer wall had absorbed the initial impact. The air gap had let the blast disperse. The inner wall had stopped what little remained. It violated every instinct. Soldiers wanted protection close, wanted it solid, wanted it now. The idea of deliberately leaving space between you and the enemy felt wrong at a visceral level. Henderson got that. He just thought it might also be right. He'd tried to explain it to Lieutenant Morrison 3 days earlier, when they'd first occupied this position on Aachen's outskirts. "Sir, the German 88s hit with enormous force. A solid wall just transmits that energy straight through. But if we build 2 walls with a gap, Henderson, I appreciate initiative, but we follow doctrine," Morrison had interrupted. 4 bag-thick walls, standard construction. We've got limited time before Jerry starts ranging in on us. With respect, sir, this could save lives. So could a lot of things, Sergeant. So could staying in England. Build the positions by the book. But Henderson was a sergeant with 20 years in the Corps before the war started, and he knew the unwritten rule. Officers gave orders for the platoon, but NCOs had latitude with their own squads. So while the rest of 2nd Platoon built standard positions, Henderson's squad built something different. The outer wall went up first, sandbags stacked in the regulation overlapping pattern, but only 2 bags thick instead of 4. Then came the gap 3 feet of empty space that made every man in the squad nervous. Finally, the inner wall, another 2-bag thickness, this one with firing ports carefully positioned. Sarge. This is insane, Private Kowalski had said, stacking bags on the inner wall while glancing nervously at the exposed gap. If a shell hits that outer wall, we're sitting here like ducks in a shooting gallery. If a shell hits the outer wall, that's exactly what saves you, Henderson replied. He picked up a clod of frozen earth and threw it hard at a sandbag. It hit with a thump and stopped dead. Now, watch. He threw another clod, just as hard, at a sandbag 3 feet behind the first. The first bag caught most of the impact. The second one barely moved. Shells ain't clods of dirt, Sarge. No, but physics is physics. Blast energy needs something to push against. Give it nothing but air, and it disperses. The skepticism in the squad was palpable, but they built it anyway. You didn't argue with Henderson not because he pulled rank, but because he had a way of being right about things that seemed wrong. By the evening of November 2nd, Henderson's position was complete. 2 parallel walls of sandbags with 3 feet of empty space between them, fighting positions behind the inner wall, overhead cover from scavenged timber and more bags. It looked vulnerable. It looked wasteful. It looked, as Corporal Davis had so eloquently put it, like a sergeant lost his goddamn mind. The German artillery battery was positioned 3 miles east, in the wooded hills beyond Aachen's ruins. The crews had been pounding American positions for 6 days, and they'd gotten good at it. Forward observers called in coordinates. Crews adjusted aim. 88mm shells screamed across the broken landscape with terrifying accuracy. On November 3rd, at 09:15 hours, they found Henderson's position. The first shell hit 40 yards short, throwing up a geyser of frozen earth and shrapnel. The second hit 30 yards short. The German gunners were walking their fire in, adjusting with each shot, and everyone in 2nd Platoon knew what came next. Incoming! Someone shouted unnecessary, since the distinctive shriek of an 88 gave you about 2 seconds warning if you were lucky. The third shell hit the outer wall of Henderson's position dead center. The sandbags exploded outward, in a spray of burlap and sand. The blast was enormous, a compression wave that you felt in your chest before you heard it with your ears. Smoke and dust filled the air. For a moment, nobody could see anything. Corporal Davis, in his standard 4-bag-thick position 20 yards away, waited for the screaming to start. That's what happened when 88s hit positions. You heard screaming, or you heard nothing, and nothing was worse. He heard Henderson's voice instead. "Everyone check in. Kowalski here. Sarge. Martinez, all good. Johnson's okay. Walker, present and scared shitless." Davis stared. The outer wall of Henderson's position was wrecked, bags torn open, sand scattered across frozen ground. But the men behind the inner wall were climbing back to their firing positions, shaking off dust, checking their weapons. Not one casualty, not even minor wounds. "What the hell?" Davis muttered. The German gunners, unaware of what had just happened, fired again. Shell hit just behind Henderson's position, but close enough that shrapnel screamed through the air where the outer wall had been. The inner wall caught it. The men behind stayed down and stayed safe. Lieutenant Morrison came sprinting over during the next lull in the shelling, sliding into Henderson's position with his eyes wide. "Sergeant, report." "No casualties, sir." "Positions holding." Morrison looked at the destroyed outer wall, then at the intact inner wall, then at Henderson. "Sergeant, is this that crazy double wall idea you wanted to try?" "Yes, sir." "It worked." "It worked," Morrison repeated. He looked at the smouldering remains of the outer wall again, doing calculations in his head. A direct hit from an 88. 0 casualties. "Sergeant Henderson, I want every position in this platoon rebuilt like yours. Starting now." "Sir, we don't have enough bags for—" "Then we'll use half as many per position and build twice as many positions. Move." Word spread fast in a combat zone. By that afternoon, officers from other companies were walking the line, looking at Henderson's position, asking questions. By the next morning, engineers were taking photographs and measurements. By the end of the week, field manuals were being rewritten. The principle was simple once you understood it. An 88 shell carried tremendous kinetic energy that needed to be dissipated. A solid wall absorbed the impact, but transmitted the shock and shrapnel straight through. Two walls with a gap forced the blast to expand into empty space, losing energy with every inch it traveled through air instead of solid matter. The outer wall disrupted the shell's penetrative force. The gap dispersed the blast. The inner wall stopped what little remained. It was spacing that mattered, the same principle that made the German Schürzen side skirts effective on tanks, the same principle that would later influence the design of modern spaced armor. But Henderson hadn't known the theory. He'd just watched what happened when shells hit things, and he'd thought about how to make men survive. The resistance to the idea had been institutional and instinctive. Solid walls felt safer than gaps. Dense protection felt smarter than dispersed protection. The field manual's 4-bag thickness had been tested and proven, except it had been proven against different threats in different circumstances. The 88 was something new. Velocity and explosive force combined in ways that made old solutions inadequate. Henderson's innovation hadn't come from engineering genius. It had come from observation, from asking why casualties happened where they did, from being willing to test an idea that felt wrong to everyone else. That's how most battlefield innovations worked, not in research labs or testing grounds, but in frozen Belgian fields where the price of being wrong was measured in body bags. On November 7, 1944, the 1st U.S. Army issued a tactical bulletin describing the double-wall sandbag method for defending against German artillery. It recommended a minimum 3-foot gap between walls, with the outer wall serving as an explosive barrier and the inner wall providing personnel protection. The bulletin credited field innovations by combat units, without naming Henderson specifically, because that's how the army worked. But in 2nd Platoon, outside Aachen, everyone knew. The sergeant who'd built the stupid position had probably saved a dozen lives in that first shelling alone. Over the next weeks, as the technique spread, the number climbed. No one could count exactly how many men survived 88 strikes because of spaced sandbag walls, but engineers estimated it reduced casualties from direct artillery hits by approximately 40% compared to standard construction. 40%. That meant 4 men walking away where there should have been none. That meant letters home that got written instead of letters home that arrived in black-bordered envelopes. Corporal Davis, who'd mocked the idea loudest, ended up building his own double-wall position on November 5th. When it took a direct hit on November 9th, he walked away with nothing worse than ringing ears and a newfound respect for sergeants who read German manuals in foxholes. Jimmy Kowalski, years later, would tell his children about the morning he watched an 88 shell blow apart an outer wall while he crouched behind the inner one, completely unharmed. It looked stupid, he'd say. It looked like the kind of thing that gets people killed, and it saved my life. The 88mm gun remained a feared weapon through the war's end. But after November 1944, Allied field fortifications adapted. The solid wall gave way to spaced barriers. The doctrine changed, and men like Henderson proved something important. Sometimes survival meant ignoring what everyone knew was right, and trying what everyone knew was wrong. The technique spread through the American lines like fire through dry grass, but not without friction. Military bureaucracy moved slowly, and battlefield innovation moved fast, and the gap between them created tension that played out in command posts and supply depots across the Western Front. Major William Brennan of the Corps of Engineers received the first official report about Henderson's position on November 9th. He read it twice, frowning, then called in his chief technical advisor, Captain Robert Chen, a pre-war civil engineer from San Francisco who'd designed earthquake-resistant buildings. "Bob, look at this. They're saying spaced sandbag walls reduce 88 casualties by 40%. Chen studied the report, his eyes moving across the diagrams and photographs. "The physics make sense, sir. It's the same principle as crumple zones in vehicle design or isolation joints in buildings. You're creating a buffer that absorbs and disperses energy. Then why isn't it in the manual? Because the manual was written for stopping rifle fire and shrapnel, not direct hits from high-velocity artillery. The threat changed. The doctrine didn't. Brennan leaned back in his chair, thinking about the implications. If this works, and the field reports say it does, we've been building positions wrong for months. That means men died who didn't have to. Yes, sir, that's exactly what it means. The weight of that realization hung in the room. Brennan picked up his phone and called 1st Army headquarters. Within 48 hours, engineering teams were conducting live-fire tests at a training range in Belgium, using captured German 88 guns to verify what Henderson had discovered in combat. The tests confirmed it. A standard 4-bag thick wall, when hit directly by an 88 shell, transmitted approximately 60% of the blast energy through to the protected side. Casualties in test positions with dummies, registered as severe to fatal. But a double wall system with a 3-foot gap reduced transmitted energy to less than 20%. The casualties dropped to minor injuries, or none. It's counterintuitive, Chen explained to a room full of skeptical officers on November 15th. Everything in our training tells us that more mass equals more protection. But against high-velocity projectiles with explosive warheads, it's not about mass, it's about energy dissipation. The air gap matters more than the bag thickness. A colonel from the 3rd Army raised his hand. Captain, are you telling me we should use fewer sandbags per position? I'm telling you we should use them differently, sir. 2 thin walls with a gap provide better protection than 1 thick wall, and they use the same amount of material. But it looks weaker. It looks weaker, sir. It performs better. The distinction mattered. In war, appearances shaped morale. Soldiers trusted thick walls because thick walls looked safe. Asking them to trust empty space required explaining the physics, and most infantry sergeants weren't physics teachers. The technique would only spread if men believed in it, and belief required proof that was visceral and immediate. Henderson understood this better than the engineers. On November 20th, when his platoon received replacements, green troops fresh from England who'd never heard an 88, he didn't lecture them about blast energy and air gaps. He just built the walls and let them see. The demonstration came 3 days later. German artillery opened up at dawn, and a shell hit the position occupied by 2 of the new men, Privates Castellano and Wright. The outer wall exploded. The inner wall held. Castellano and Wright emerged, shaking but unhurt, and the rest of the replacements started rebuilding their positions with gaps that afternoon. You can explain it all day, Henderson told Lieutenant Morrison, but nothing teaches like walking away from a direct hit. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The adoption wasn't universal. Some units stuck with standard walls, either from inertia, skepticism, or simple lack of information. The contrast became visible in casualty reports. Companies using spaced walls reported 30 to 40% fewer artillery casualties than companies using solid walls, even when facing the same intensity of German fire. By December 1944, the pattern was clear enough that division commanders started asking uncomfortable questions. Why were some units losing more men to artillery than others? The answer that some units had adapted and others hadn't created pressure for standardization. But standardization required rewriting doctrine, and doctrine moved at the speed of committee meetings and field manual revisions. The new technique was saving lives in November, but it wouldn't officially enter Army regulations until February 1945. The lag killed men who might have lived. Private Eddie Merrick died on December 8th outside Hurtgen Forest, behind a regulation 4-bag wall that took a direct 88 hit. His squad leader had heard about the spaced wall technique, but hadn't been authorized to deviate from standard construction. 3 weeks later, the authorization came through. It was 3 weeks too late for Merrick. This pattern repeated across the front. Innovation in the field, validation by engineers, resistance from doctrine, eventual adoption, and in the gap between discovery and implementation, casualties that didn't have to happen. It was the eternal friction between the speed of battlefield necessity and the caution of military bureaucracy. The Germans noticed the change. Forward observers reported that American positions were being built differently, with what looked like incomplete or damaged outer walls. Intelligence officers analyzed photographs and eventually figured out what was happening. By January 1945, German artillery doctrine was advising crews to adjust their targeting for spaced fortifications, though the practical effect was minimal. The physics still favored the defenders. What the Germans didn't know what they couldn't know from observation was the psychological dimension of Henderson's innovation. The spaced wall technique didn't just reduce casualties. It changed how men thought about survival. In a solid wall position, you knew that a direct hit meant you were probably dead. You accepted it, the way soldiers have always accepted the lottery of artillery. But in a spaced wall position, you'd seen men walk away from direct hits. Survival stopped being luck and started being engineering. That changed something fundamental about morale. Henderson saw it in his squad. Men who'd been fatalistic about German artillery started believing they could survive. They stopped flinching at every distant crack of an 88 and started trusting the walls. The fear didn't disappear. Artillery was always terrifying, but it became manageable in a way it hadn't been before. Lieutenant Morrison saw it in his platoon's performance. Troops who believed they could survive fought harder and thought clearer under fire. The spaced walls did more than reduce casualties. They reduced combat stress, improved fire discipline, and maintained unit cohesion during bombardments. By January 1945, the technique had spread beyond sandbag walls. Engineers started applying the same principle to concrete fortifications, building pillboxes with spaced outer shields. Armor units began experimenting with spaced plates on tanks, thin outer plates with air gaps before the main armor. The concept that Henderson had discovered with sandbags in Belgium influenced defensive design across multiple domains. The irony wasn't lost on Henderson. He'd spent 20 years in the peacetime corps, following regulations, respecting doctrine, doing things by the book. Then war came, and survival required ignoring the book. The same institution that had trained him to follow rules now rewarded him for breaking them. On February 1, 1945, Henderson received a Bronze Star for tactical innovation resulting in significant casualty reduction. The ceremony was brief, conducted in a muddy Belgian field between artillery barrages. The medal went into his pack. What mattered more was the letter from Major Brennan that came with it. Sergeant Henderson, your field innovation has been incorporated into updated defensive doctrine effective February 5, 1945. Engineering estimates suggest this technique will reduce artillery casualties by 30 to 40% going forward. On behalf of the Corps of Engineers and the men who will benefit from your work, thank you. Henderson showed the letter to Kowalski, who'd been with him since Normandy. 30 to 40%, Jimmy. That's thousands of guys who'll walk away from hits that would have killed them. All because you built a weird wall, Sarge. All because I looked at what was killing us and thought about how to stop it. That distinction mattered. Henderson hadn't invented anything new. Spaced armor concepts existed in engineering textbooks. The Germans had been using Scherzen plates on tanks since 1943. The principle was known. What Henderson had done was apply it in a new context, under fire, with materials at hand, despite skepticism from everyone around him. That was the real innovation. Not the technical solution, but the willingness to try it when conventional wisdom said it wouldn't work. The technique saved Private Walker's life on February 9th. An 88 shell hit the outer wall of his position, blew it apart, and Walker emerged from behind the inner wall with nothing worse than temporary deafness and a profound appreciation for physics he didn't understand. It saved Corporal Martinez on February 23rd, when a near miss threw shrapnel through the gap between walls, most of the fragments losing energy in the empty air before they reached the inner barrier. It saved men whose names Henderson never learned, in divisions he never served with, in battles he never fought. The technique spread through the European theatre like doctrine should have spread but didn't, carried by survivors who told other troops what had saved them, built by sergeants who trusted field experience over training manuals. By March 1945, the spaced sandbag wall was standard construction in most American units in Europe. New troops learned it in training. Veterans rebuilt old positions to incorporate it. The stupid wall became the smart wall, and the solid four-bag barrier became obsolete. But the transition hadn't been clean or quick. Between November 1944, when Henderson first built his position, and March 1945, when the technique became universal, hundreds of men died behind solid walls that might have saved them if they'd been spaced. That bothered Henderson more than the medal. On quiet nights, he'd think about Merrick and the others, men he'd never met, who'd died defending positions built to old standards, while the new standard was being proven 50 miles away. The friction of institutional change, measured in corpses. War had always worked that way. Innovation came from necessity. From men like Henderson who watched what killed their friends and thought about how to prevent it. But adoption came slowly, grinding through layers of skepticism and bureaucracy, while the old methods kept killing people. The 88mm gun remained lethal through the war's end. German crews fired them right up to May 1945, and Allied troops still died under their barrage. But the casualty rate dropped. The spaced walls worked, and men who would have been statistics became survivors, because one sergeant had built something that looked stupid but performed smart. Private Jimmy Kowalski made it through the war. He came home to Pennsylvania in November 1945, married his sweetheart, raised 3 kids, and never missed a chance to tell the story of the morning. He crouched behind Henderson's crazy double wall, while an 88 blew the outer barrier to shreds, and he walked away without a scratch. Sergeant Tom Henderson stayed in the Army after the war, made Master Sergeant, and retired in 1954. He never talked much about the Bronze Star or the innovation that saved thousands of lives. When people asked him about the war, he'd just say he'd done his job, which was keeping his squad alive. The field manual was updated. FM 5-15, revision of 1946, included detailed specifications for spaced sandbag fortifications, with diagrams showing proper gap, distances, and wall thicknesses for various threat levels. The manual credited field innovations during the European campaign without naming names, because that's how official documents worked. But in the Corps of Engineers, in the armour schools, in the infantry training centres, instructors told the story of the sergeant outside Aachen who'd built the wall that everyone said wouldn't work. They told it because it illustrated something important about warfare, that survival often came from questioning doctrine, from applying principles in new ways, from being willing to try things that looked wrong until they proved right. The double-wall sandbag technique represented something larger than its immediate tactical value. It was an example of how military organizations learned slowly, imperfectly, with friction between field innovation and institutional adoption, but eventually incorporating the lessons that combat taught. It also represented the hidden cost of that learning process, the gap between when something was discovered and when it became doctrine, and the casualties that fell into that gap. Henderson's innovation was proven in November, validated by engineers in December, but didn't become official until February. That 3-month lag had a body count attached to it. The same pattern repeated throughout military history. Somebody figured out something that worked. It spread informally through word of mouth and field observation. Eventually, the institution caught up and made it official. And in between, men died using the old methods, while the new methods were being proven elsewhere. This wasn't stupidity or malice. It was the inherent friction of large organizations, the necessary caution of systems that couldn't afford to adopt every field innovation without vetting it, the structural lag between tactical discovery and strategic implementation. But understanding why it happened didn't make it less tragic. Private Eddie Merrick, who died behind a solid wall 3 weeks before the new technique was authorized, deserved to have lived, so did the hundreds of others who fell in that gap. Their deaths weren't meaningless, they contributed to the institutional knowledge that eventually saved thousands, but they were preventable in hindsight, and that made them harder to accept. Henderson understood this. On April 7, 1945, he was helping a new lieutenant position his platoon's defences when the officer asked him about the spaced wall technique. "Sir, I learned about this in training, but I still don't really understand why it works." Henderson picked up 2 sandbags and set them 3 feet apart. The shell hits the first bag, releases all its energy trying to get through, but there's nothing behind it except air. The blast expands into empty space, loses force with every inch. By the time it hits the second bag, it's spread out, weakened. The second bag stops what's left. That simple? The physics is complicated. The idea is simple. The hard part was getting people to believe it. But now it's standard doctrine. Henderson agreed. Took 4 months and a few hundred casualties, but we got there. The bitterness in his voice was subtle but real. The lieutenant heard it and didn't know what to say. Henderson picked up another sandbag and went back to work. You couldn't change the past. You could only build better walls for the future. The war in Europe ended on May 8, 1945. The final artillery barrage had been fired, the last 88 shell had been launched, and the men who'd survived behind spaced sandbag walls went home to tell stories about the sergeant who'd saved their lives by building something that looked stupid. The technique survived the war. It influenced post-war defensive doctrine, informed the design of modern spaced armor, and became a standard example in military engineering courses of how battlefield innovation could reduce casualties through applied physics. But for the men who'd lived it, the story was simpler. There had been a wall that killed you when shells hit it, then a sergeant built a different wall that didn't. One wall was stupid until it wasn't. The other wall was smart until it was obsolete. That was how war worked, how innovation worked, how survival worked. You questioned what everyone knew was right. You tried what everyone knew was wrong. And sometimes, not always, but sometimes you walked away from direct hits that should have killed you because somebody had been willing to look stupid in order to be smart. Private Kowalski, 50 years later, would stand in a veterans' cemetery in Pennsylvania, looking at Tom Henderson's headstone. The inscription listed his rank, his service dates, his decorations. It didn't mention the wall. But Kowalski would tell his grandchildren about it anyway, because some stories mattered more than inscriptions. Your great-grandfather was there, he'd say, pointing at the stone. November 3rd, 1944. A German shell hit the outer wall, and I thought we were all dead, but we weren't, because Sergeant Henderson had built something that everyone said was stupid, and it saved 12 men that morning, probably saved thousands more before the war ended. Did people stop calling it stupid? One of the kids would ask. Eventually. But it took a while. That's how new ideas work. They look stupid until they're proven, and then they look obvious. But somebody's got to be willing to look stupid first. That was the lesson that lasted longer than the technique itself. Innovation required courage, not the courage to face enemy fire, though that mattered too, but the courage to face skepticism from your own side. The courage to build something different when everyone else was building the same thing. The courage to trust observation and reasoning over received wisdom. Tom Henderson had that courage on a frozen morning outside, Aachen, and it made the difference between men dying and men surviving. The wall he built wasn't the first innovation of the war, and it wasn't the last, but it was his, and it worked, and that was enough. The German 88mm gun earned its reputation as the most feared artillery piece of World War II. It was accurate, powerful, versatile, and lethal. But against properly constructed spaced fortifications, its lethality dropped by 40%. Physics beat firepower, engineering beat explosives, and a sergeant who'd been willing to look stupid had given thousands of men a chance to walk away from impacts that should have killed them. That was the real story behind the stupid sandbag trick. Not that it stopped 88 shells cold, no sandbag wall could do that, but that it transformed direct hits from certain death to probable survival. It changed the odds. And in war, changing the odds was how you saved lives. Thank you for watching. For more detailed, historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.